Hello world, it's Rahul. Welcome back guys to machine learning tutorial. Today we'll be discussing simple linear regression. So guys, regression is nothing but relationship between dependent and independent variables. Now question arises, what are these dependent and independent variables? Let's quickly understand this with some example. Suppose you want to check your loan eligibility, whether you are eligible for getting a loan or not. Simply yes or no condition. So the factors which are affecting this, like your salary slab, monthly consumptions, proof of identity, proof of residence, will come under independent variable and your eligibility column will be dependent variable. Okay, so why we are saying this as a linear regression? What do you mean by term linear? As the value of x increases, so will the value of y increases as shown in figure. So we can see the linear relationship over here, and this relation can either be positive or negative. Just to add one more thing, if we have more than one independent variable or factor which is affecting the output or dependent variable, then we'll categorize that into multiple linear regression, otherwise simple linear regression. So guys, for our case we'll have only one dependent and one independent variable as of now. So guys, let's quickly see one example. Suppose we have a data which is having x column as size of house in square feet and y column as price in dollars. So we have data points calculated like shown in the figure. We are trying to create a best fit line using regression equation such that we can find out the price for my particular future size of house column. For drawing best fit line, we can make use of equation y is equal to mx plus b. One point to add is that best fit line must passes through mean of x and y coordinate. Now question arises, what is m and c, as we are already aware with x and y values. So guys, m is a slope, that is nothing but unit change in my x coordinate will definitely change y value. So if I consider point 2 of x axis and then shift to point 3, then my slope will be 1 as x has shifted with a unit value, and same applies with y. And b is y intercept, means where this best fit line is intercepting the y-axis. Till now we have studied that for solving linear regression problem, we have to find the best fit line for our data points. But how can we get this best fit line? So one of the best approach is to draw multiple lines over the scattered data points, that is nothing but independent variables, and try to find the distance between points and line. Then our goal is to minimize this distance as much as possible to minimize the error. Now our main focus should be on reducing error and getting accurate value of m and c parameters, that is nothing but regression coefficient. So guys, we'll use least square error technique in this tutorial, and we'll see how we can reduce error by using gradient descent in next tutorial. So guys, why only least square error? One reason is that the equations involved in solving for the best fit line are straightforward, as can be seen in the above example. Equations involving absolute value functions are more difficult to work with than polynomial equations. Another qualitative reason is that it is generally preferred to penalize a single large error rather than many medium-sized errors. Now we have great understanding of simple linear regression. Let's deep dive into mathematical approach and try to find the value of m and c, best fit line, and reduced error. As we can see, we have a data set of x and y columns with size of house and price values, and if we see at the rightmost, we can find the scattered data points representations as well. So guys, according to y is equal to mx plus b equation, we have to find out value of m and c using regression equation. I have mentioned the formula, that is we'll subtract each data points with its mean value and divide it by square of this difference. Let's consider size of house as x and price as y for the moment. So we have 6 values of x column, that is 1, 2, 3, 4, 5, 6. For finding mean of x column, we'll add these values and divide it by the total number of values present in the x column. Same will do for y column for finding y mean. Now we have values of x mean and y mean. So according to formula, we have to calculate x minus x mean, y minus y mean, multiplication of x minus x mean, y minus y mean, and square of x minus x mean for each data points, like 1 minus 3.5 will be minus 2.5 and 4 minus 5.16 will be minus 1.16 and likewise. After this, we'll make summation of both multiplication of x minus x mean and y minus y mean value and square of x minus x mean value. After putting this value in equation for finding slope, I'll get it as 0.713. By same means, we can get value for y-intercept, that is 2.664. Now we have values for both slope and y-intercept, that is m and b. Let's substitute this into final equation, that is y is equal to mx plus b. Now we can see the value of y for each value of x. So guys, if you can see the difference, our predicted value is somewhat changed from actual one, and we can directly calculate the error by subtracting predicted y value from actual y value. We can iterate through this process till best finding of regression coefficient. So guys, if you can see red dots in the graph visualization is nothing but predicted value of y in correspondence to x. So according to this observation, we can say now that these red dots are creating best fit line for this dataset with minimum amount of error and minimum distance of each data points with this line. So guys, we'll cover mentioned bullets in next tutorial, that is reducing error through gradient descent, Python code from scratch for predicting simple linear regression outcome on actual dataset, and we'll code using scikit-learn library as well. Thank you guys for your time. Do like, share and subscribe. Hit the bell icon to get the latest updates. Happy learning and stay safe.